All right. So we're gonna watch two sets of notes today. This first one is pretty quick, and it's learning something called the difference quotient. The difference quotient is something that we'll learn a lot more about later on in the year. It has a direct connection with calculus, but we're just going to practice right now using the difference quotient to simplify. So we're not going to do a lot with the meaning behind it. We're just going to practice simplifying this difference quotient. So the difference quotient is this big equation. That is your difference quotient. So it's your function when you evaluate it with x plus a in the equation minus your equation that you started with, all divided by the constant a. So what we're going to do is we're going to do two examples here. The first one, we're going to use this function, and we're going to simplify it using the difference quotient. So what we want to remember is that this right here, this x plus a, that's what we plug in for x when we're evaluating. It's just like if it was a number. If we said f of 2, we would plug in 2 for x and then simplify. Well, here we're doing f of this expression, so that whole expression has to go in for x. So this first part will be 5 times x plus a minus 4. All of that is f of x plus a. Then we're going to have minus f of x. Well, f of x is just our equation. So we're going to have minus 5x minus 4. Oops, I did brackets. So this is f of x. All over a. Okay, so to start off, that's just the setup, the plugging our function into the difference quotient. We haven't done anything, that's just the evaluating part. Okay, this is also usually the part where most people have questions. So if this part right here, the plugging it in and getting it set up, is confusing, make sure you ask about it tomorrow. So we can definitely go over it. We are going to do a third example in class using the difference quotient. Okay, so now once you have it all plugged in, it's just simplifying. So we can go to our, whoops, drop that pen. So inside our parentheses, we can distribute the 5. So 5x plus 5a, and then we have minus 4. Over here, I can distribute the negative so that I can drop my parentheses or brackets all over a. So on top, I can combine like terms. 5x and negative 5x add up to 0. Negative 4 and positive 4 add up to 0. So we're left with 5a divided by a. The a's cancel, and you get an answer of 5. Sometimes we get an answer that's just a number. Sometimes we'll get an answer that is another expression with variables in it. Okay? Either one for now is fine. Later in the year, we're actually going to put some meaning behind what this formula is. But for right now, we're just practicing the evaluating. So the plugging in and the getting out of an answer after simplifying. Okay, but that right there is really all there is to it. So again, like I was saying, usually the hardest part is the plugging in because it's an expression, not just a number that we're evaluating. So we're going to do another one just to get some more practice and see it again. And like I said, we'll do a third one in class. And so here we're going to find g of x plus c minus g of x over c. So hopefully you can see that it's this equation that I just wrote. It's still a difference quotient. It just uses some different letters than the one above, but it's still a difference quotient. Has that same format of g of an expression, x plus something, minus the function over a constant. So again, we want to start this problem by just plugging things in. So the first thing I need to do, this x plus c has to go in for both x's. Because again, if it was a number, we would plug that number in, but since we have an expression, we're plugging an expression in. So we'll have x plus c squared plus 3 times x plus c. Okay, so again, this is our g of x plus c expression. We have our x squared plus 3x, but instead of x, we have our expression in there. Minus, next up is our g of x. Oops, this should have been a g. Our g of x would just be our equation as it is, x squared plus 3x all over c. So we have, this is our g of x plus c, this is our g of x, and we have our constant on the bottom. Okay, from this point, we're going to start to simplify. So once it's all plugged in, we're just going to simplify, combine like terms, and try to go from there. So I have to FOIL this out. So when we write it out twice and multiply it, we'll get x squared plus 2xc plus c squared. Over here, we'll distribute plus 3x plus c. Here we'll distribute the negative, so minus x squared minus 3x all over c. We can simplify on top. So I have x squared and negative x squared. Those add up to 0. I have a negative 3x and a positive 3x, which also add up to 0. So with what I have left, I have a c squared, I have a 2xc, and I have a c. On top, I notice I can factor out a c because they all have a c in common. Except I just noticed a mistake. This is supposed to be a 3c. So this is supposed to be a 3c. So this is supposed to be a 3, not a 1. Once we factor it out, we can cross the c off. And with what we're left, c plus 2x plus 3, that would be our final answer. Sorry, guys. So like I said, we're going to do one more of these where we're going to be given a function and we're going to plug it in and evaluate it using this difference quotient. You do have one of these on your test, and it's going to become really important when you guys take calculus, and even later this year when we start learning the beginnings. So this again is just our practice with the evaluating and simplifying. We're going to put meaning behind it a little bit later. So if you have any questions, please note them and we can go over them at the beginning of class.